Hey, Algebra 1 students, these notes or this video is for Chapter 8, Section 8.1. Day 1 probably is all that will be in this video. So in your note packet, we will actually be starting on page 5. So in your note packet, if you can turn to page 5 or find the vocabulary section, that's where we're going to be started. So this is all about quadratic functions and graphs that we call parabolas. So in chapter 7, we did a lot of factoring of equations that had x squareds in them. Those equations that have x squareds are called a quadratic equation or quadratic function. So a quadratic function is a function that has an x squared. So I'm going to zoom this in a little bit. A function that has an x squared. So for example, we looked at some like this in chapter 7. When you graph a function with an x squared, I'm going to flip back here for a minute just to show you, it's going to have this U-shaped, either upward facing, which I call a smiley, or it could be downward facing. That graph that is a graph of a quadratic function we call a parabola. So a parabola is the U-shaped graph of a quadratic function. This is how I like to abbreviate function, fxn. Remember, if you need to, pause the video and then fill in the notes if this is going fast. The vertex, I'll show you right down here, is this point right here. It's going to be either at the bottom or the top of the parabola. Remember, the parabola is the graph. So we call that the turning point because you can see right here, this graph is decreasing, and then when it gets to that vertex, it changes directions and starts increasing. So vertex is the turning point of the parabola. Remember, the parabola is the graph. One thing I'm going to have you add up here on the parabola is parabolas are always symmetrical. So they are the same on the right as on the left. And the line that splits the parabola right down the middle or in half, right here it's shown, is called the axis of symmetry. So this is a line that passes through the vertex, a line that passes through the vertex, splitting, oh, there goes my phone, hang on a moment. Splitting the parabola in half. Okay? It is a line. So it's actually a vertical line. So the equation for vertical lines are always x equals. So vertical lines are x equals. So axis of symmetry will always be written as x equals. All right, let's look at example 1 where we go through finding these characteristics of a quadratic function or a parabola. So here is the parabola that we are interested in. So I'm going to fill in the information here and then put it over here. Now, the first point that you want to locate is the vertex. And it's also probably the easiest one to see. So that is the vertex. We want to write it as a coordinate point. And so it would be over -1 up 1. So over -1 up 1 is my vertex. The axis of symmetry is the line that passes through the vertex. It's right there. So it's already drawn. I abbreviate this axis of symmetry like that. It is a vertical line. So we have to write x equals, and the x value that it goes through is -1. Every single point on this line has an x value of -1. So x equals -1 is the equation for the axis of symmetry. When you're figuring out increasing and decreasing, you want to start on the left side of the parabola. And then picture yourself on a roller coaster. If you're on the roller coaster over here, you're going down. This would be the bottom of the hill, and then you would start going up. So this is decreasing, and this side is increasing. Now, when we describe where we're decreasing and increasing, we want to use an inequality, so a greater than or less than. So I want you to think the middle is at x equals -1. So I want to use an x and I want to use a -1. But I want to say I'm on the left side of the middle. Here's the middle. I'm on the left side of the middle. Notice this arrow is pointing to the left because I'm on the left side. So write your inequality pointing in the same direction. So this says for all x values less than -1, that would be all of these, my parabola is decreasing. Right here it changes directions, that's the turning point, and on the other side of the middle, so the middle is at -1, the other side of the middle would be the right side. See, this arrow is pointing to the right. So point your inequality to the right. Domain and range. First of all, let's remind ourselves that domains are x's and range are y's. So this is asking what are all the x's that are on the graph of the parabola and what are all the y's. So domain is x's, and so the x-axis goes right and left. So you want to think where is the right side of the graph and where is the left side of the graph. When we did this in semester ones, our graphs mostly had ending points. If you look here, this graph has arrows here, so that means it's going forever. So this graph starts out and it gets wider and wider and wider, and it keeps going up and up and up. It also keeps getting wider and wider and wider. So if you tried to find where does the left side end, you couldn't find it because it's going to keep getting wider forever. If you tried to find where does the right side end, you couldn't find it because it's getting wider forever. So we say, well, every x is part of the domain. So you want to say all real numbers are the domain. There is a shortcut way for writing all real numbers. So I'm going to say, or you could use this symbol. I like to call it the double-legged capital R. This symbol means all real numbers. So the domain for a parabola will always be all real numbers. The range will change depending on your graph. So if you look at this graph, you can think these arrows are going up forever. So I can't find the top of the graph. But this right here is the bottom. The bottom of the graph is right here. This is the lowest point on the graph. And so range are y values. So you want to think, where is the top and where is the bottom? So I'm going to say it has no top because it goes up forever. The bottom is at that vertex, which is -1, 1. Now, for range, I'm only concerned with y values. So I'm going to put a y, and then I'm going to put the y from my vertex. Because if you look at the graph, the bottom of the graph is right here at y equals 1. So the bottom is at 1, which means the very smallest y value is 1. So I want to put my inequality, the little tiny point, pointing towards the 1, because this 1 is the bottom, or you could think the smallest. The rest of the y values are above the vertex. So those would be greater than. We also want to put our equal to line under there because y equals 1 is part of the domain. So the domain is every y value greater than or equal to 1. All right. Yeah, I'm going to say that is the first part of 8.1. So this will be video number 1 for 8.1.